Hey guys, I'm Jack, and today we will study about Chapter 3, Partial Derivative. So let me explain what is partial derivative. A partial derivative is a way to find how a function changes with respect to one variable while keeping another constant. So a partial derivative, let us study how the function changes when only one variable changes. Now we will learn about ordinary derivative. Ordinary derivative is used when a function has only one variable. It measures how the function changes when that one function is changed. Let me show you an example. Y equals to x squared. So first, we need to use this formula. dy dx is equal to nx power to n minus 1. So the n is the power lah, which is 2. So we just need to throw in front of the x 2, and then the power of 2 minus 1. So become 2x. So now we will learn the partial derivative. So partial derivative is used when a function has more than one variable. It measures how the function changes with respect to one variable at a time while keeping another constant. Just now the ordinary derivative is only one variable, and this one is more than one variable. So now we will do an example. Fxy is equal to 3x squared y cubed plus 4xy. So we need to find the partial derivative of x and partial derivative of y. So we need to separate into two terms first, which is 3x squared y cubed as the first term and 4xy as the second term. So first we treat y as constant and differentiate each term. 3x squared y cubed after we differentiate will become 6x y cubed because we treat y as constant, so we only differentiate x, so becomes 6xy cubed, and the 4xy also same, differentiate become 4y because we differentiate the x and keep the y constant, and then we plus the both together become 6xy cubed plus 4y because here is a plus. And then now we do the partial derivative of y. So 3x cubed, 3x squared y cubed after we differentiate become 9x squared y squared. And the 4xy also same. After differentiate become 4y. And then we just plus them together become 9x squared y squared plus 4y. We will do the second order partial derivative. Second order partial derivative means you take the partial derivative twice. First, differentiate the function once, then differentiate the result again. So, for example, x squared y cubed. First, we need to do the first partial derivative with respect to s. So, become 2xy cubed because the y is constant. Same with the first derivative, partial derivative. And then we do the partial derivative to y and become 3x squared y squared. Because we throw the 3 in front to the x. And the second derivative, we need to same like just now. We need to do the second derivative respect to s. So become we use the 2xy cubed to differentiate, become 2y cubed. And then for the y, also same. We also differentiate this 3x squared y squared. So it becomes 6x cubed, 6x squared y. We will do the mixed derivative. Mixed derivative is just need to differentiate with respect to x, and then differentiate the result with respect to y. Now we do an example. Fxy is equal to x squared y cubed. We just use the previous example. So we need to find the derivative of x. So we keep the y constant. It so become 2xy cubed. Now we keep the x constant and we throw the y in front to the x. So become 2x squared y. So this is mixed derivative. Now I will explain the real-world engineering application which can be used the partial derivative. I will explain the temperature distribution. So in real-world engineering system, temperature usually depends on more than one factor. For example, temperature on a metal plate depends on horizontally position, which is x, and vertically position, which is y. So the engineers model the temperature as Txy. This means temperature change at different locations on the surface. After that, I will explain the heat transfer engineering. In heat transfer engineering, heat naturally flow from higher temperature to low temperature. The direction of fastest heat flow is determined using partial derivative. Engineers combine this derivative to form something called the temperature gradient, which is delta T. This tells the direction of heat travel and how fast can the heat move. So for the last part, I will explain the importance of partial derivative in engineering. So partial derivatives are important in engineering because they help engineers to analyze systems that depends on more than one variable. They allow engineer to understand how change one factor affects the overall system while keeping other factor constant. So that's all for the topic. Thank you.